All right, we're going to finish up 3-1. We didn't quite finish it yesterday. We came close, but we didn't quite get there. So let's not review. Let's just take a look at the next little theorem here. Let me make sure this is right. Okay, good. All right, here, I'm just going to write it down. It's called the perpendicular. Have we talked about perpendicular in here before? I think we have. Really?
Yeah, I don't think we have.
Well, we talked about 90 degrees, right? Right angles. Okay, so if two lines form a 90-degree angle, those two lines are perpendicular. So there you go. That's perpendicular. Okay. So here's example. Those two lines, what are they? You sure?
90 degrees.
How do you know that's 90 degrees? You don't know. That's correct. You don't know. All right. So just by looking at it, you can't just say, "Wow, it sure looks like it's 90 degrees." You can't go by that. So, but now, what if they did this? What if they did that? Then what could you say about these two lines? Then it's perpendicular. We'll call that line L. We'll call this line M. All right. Now, technically, you're supposed to have little arrows. Sometimes I get a little lazy. Don't put the arrows there. But you get the idea, okay? You could have line segments that are perpendicular as well. You could have rays that are perpendicular to each other, all right? But this is these are lines that are perpendicular. There's a little symbol for the word perpendicular, all right? So I would say line L is perpendicular to line M, all right? So that's the symbol for perpendicular. You sure we haven't done this before? Seems like we did. Maybe it was the other class. All right, so anyway, there you go. That's the sign for perpendicular. Makes sense, right? Because two little lines, looks like it's a little right angle there. You don't have to put a little right angle symbol there. Just write it like this, and that means they're perpendicular, which means they form a 90-degree angle. Everybody good? All right, so this theorem, this perpendicular transversal theorem, is actually pretty basic, I think, anyway. So it starts off saying, if you have two parallel lines, are these parallel lines right here?
Yeah, we don't know.
You don't know. Okay, not yet. You don't know yet. All right, but if I did this, if I put an arrow right there and an arrow right there, inside, right, you know they got the arrows on the ends. What does that mean when the arrow's on the ends like this? Logan, sit down. It means it's a line and keeps on going forever, right? Okay. But if you put the arrows in here like this, what does that indicate to you?
It's parallel.
They're parallel to each other. That's right. Okay. And we have discussed this, correct? Yeah. All right. Stop. You know I'm going to say it. Why do you keep doing it? You know I was going to say something, right? Is that why you do it? All right. Watch this. We learned this word yesterday. What is this word when it crosses two lines? It's a transversal, okay? So we have a transversal. Now, here's what the theorem says. It says, if a transversal is perpendicular to one of two parallel lines, so let's draw that. If this transversal is perpendicular to one of these parallel lines, so I could put a little right angle there, what else do you think might be true about this? If it's perpendicular to the first parallel line, it's perpendicular to the other parallel line. Exactly right. And this is a theorem, so we can prove it. It's actually pretty easy proof. Because look at these two angles. If it's perpendicular, what kind of angle does it make? 90-degree angles. Right angle, 90-degree angle. Okay, so this angle right here is 90 degrees. Okay, so look at this angle and look at this angle. Is there a relationship between these two angles right here? Okay, well, I said it's 90 degrees, but even before I said that, what we learned yesterday, what's the relationship between this angle here? The angles are parallel? Angles can't be parallel to each other. You're just throwing out geometry words. You're not thinking. Okay, it's not transversal is the red line. What is true about this angle? There's a special name for it. It's a special relationship between these angles. We have a special name for it. They're corresponding, right? They're corresponding angles, okay? These two are corresponding angles. What did we learn yesterday? we learned that the corresponding angles, when you have parallel lines cut by transversal, we learned that the corresponding angles were what? What's true about the corresponding angles? Look in your notes. You should have it right in front of you. What is it? They're equal to each other. That's right. So if this is 90 degrees, then what's this angle got to be? It's got to be 90 degrees, correct? Because they're corresponding angles with each other. So that's why this is 90 degrees. That's kind of our proof. We just basically proved this theorem that said if you have a transversal that's perpendicular to one of two parallel lines, it must also be perpendicular to the second parallel line. Everybody see that? Yeah, that's pretty easy to see. Again, it's fairly basic. All right, enough of that. Let's do an example. So this is the kind of stuff you might see. Did you do the homework last night? I didn't give you homework last night?
Well, you said it.
Okay, I'm just asking. I don't remember. I'm an old man. I can't remember anything. I was looking at the lesson plans and it said you had homework, but I couldn't remember what I said. All right. Good. See, somebody remembers, unlike me, because I have a terrible memory anymore. It's what age does to you. I'll tell you the truth, I never had a great memory even when I was younger. So
I only remember like the bad stuff. Like I got stuck behind the dryer. I got a scar on my leg from the dryer.
all right. Did you draw this? Why are we talking? We should be drawing this. If whatever I put up here on the screen, you should be doing yourself. You don't have anything written on that piece of paper. Look at all the stuff that I've written down. Okay? All that stuff right there, that should be on your paper. And this should be on your paper.
What's the yellow one? Stop it.
Just draw it right now. All right, this is line A. I'm not going to bother putting the little arrows on the end of the lines. Is that all right? It just takes up too much time. So
Why do red and purple?
just write what I'm writing. And let's put this up here. They tell you something about angle 1. They say that it's 7y minus 15 degrees. And they tell you angle 2. Well, they kind of tell you angle 2. It's 10 times y plus 11 degrees. And what we want to do, here's all the information they give you. What we want to do is find all the numbered angles. So all the angles that have numbers on them, guys, all the numbers that have angle, or all the angles, I'm sorry, that have numbers, describing that angle, that's what we're trying to find. So we're trying to find out what is the actual degree or the measure of angle 1, 2, 3, 4, 5, and 6. So we got 6 answers. 6 questions, 6 answers. So we got to find some kind of relationship. I'll give you a few more seconds to finish drawing this picture. Okay. Remember, these are parallel lines. This is a right angle right here, so that's going to help you out a little bit. They kind of tell you 1 and 2, right? But they put variables here. They write it in terms of y. That's what we got to find. So we got to figure out. So what do they tell you? Angle 1. Okay, so they tell you angle 1, kind of, right? Because it's 7y. If I knew what y was, then I'd know what angle 1 was. All right, so they kind of tell you angle 1. They kind of tell you angle 2. I'm going to put 2 little arcs. Are angle 1 and angle 2 equal to each other?
No.
Definitely not. That's acute, that's obtuse. They're absolutely not equal to each other. So for angle 1, I'll put 1 arc. For angle 2, I'll put 2 arcs, just to show that they're different. Huh? Well, that's what we're going to look at, okay? But I'm just getting you started right now, okay? So they kind of tell you 1, they kind of tell you 2. So what we have to do is figure out a relationship. Now, when I say that, I remember when I was a student, I remember the teacher, professor, whoever it was when I was in college or high school, I don't know. forget exactly when, but I just remember them saying the relationship between these. And I was like, what's he talking about, a relationship, okay? Well, what is a relationship? A relationship means that you have something in common, right? When you're related to somebody, you have something in common, either your parents, your grandparents, something, right? Would you agree? All right, so what do they have in common? Like, what is the relationship between 1 and 2? Is it any of the things that we've talked about recently? All right, most likely it probably is. So let's take a look. So let's do this. What would angle 1 actually equal? Like down here, would it equal angle 2? No, because this is obtuse. That's acute. There's no way. Would it equal angle 3? No, because what's true about 2 and 3? Right. What's the relationship? Right. That's the word. What's the relationship between angle 2 and angle 3? They are. Give me a good word. I heard it. What? They're vertical angles. They're vertical angles. So 2 and 3 are equal to each other because they're vertical angles. So if 1's not equal to 2, then 1's not equal to 3. What about 4? Maybe? Absolutely, right? Parallel lines, transversal. What's true about 1 and 4? Well, they're both acute, but they're, give me a word, corresponding. They're corresponding to each other, all right? Do you see this? Let's see. It's kind of, it makes it a little more difficult with that yellow line right there because, we're used to just, we only saw it yesterday, but, we're used to seeing just 2 lines cut by transversal like this, all right? So where is angle 1? Angle 1 is right there, isn't it? Okay, where is angle 4? That would be this one right here. Now do you see them? Okay, now you see that they're what? They're corresponding, right? So what's true then about 1 and 4? They must be what? Equal to each other. But that still doesn't help me with 1 and 2, though, does it? So what's the relationship between 1 and 2? Well, 1 and 4 are equal. Tell me something about 2 and 4. Why can you add them up and get 180? Because it's a straight line. That's right. Okay. This is a straight angle, right? All right. So these 2 angles add up to make that whole straight line right there. That must mean they add up to 180. So what must be true about 1 and 2 then? If 4 and 2 add up to 180, then 1 and 2 got to add up to 180, correct? All right. And they're not like consecutive interior angles, are they? You could look at it like this. Here's another way to look at it. 1 and 3. Okay, so that would be 3 right here. I know I made that too small. Sorry about that. So there's 1. There's angle 3 right there. What's true? They're on the same side of the transversal and they're interior, right? Remember I said in my other book, I used to call them same side interior angles, but we call them what? Consecutive interior angles. What's true about consecutive interior angles? Yeah, if they're parallel lines, then they're what? They are, give me a good word. Supplementary. They're supplementary. They add up to 180. So 1 and 3 add up to 180. Well, 2 and 3 are exactly the same angles, right? So that must mean 1 and 2, what? Add up to 180. So guess what we're going to do with this angle and this angle? Add them up and?
360.
Oh, come on. You're just saying things. You're not thinking first. Okay, we've said this several times. These add up to what? We've never said 360 one time. Okay?
Because that's 180. That's 180.
No, this one we said. Listen to what I just said. Go rewind the tape and just listen to me. Angle 1 plus angle 2 equals what? 180 degrees. Not 360, 180. All right. Oh my gosh. So we're going to take, well, we don't care about 6 and 2 right now. Okay, we're just trying to find what y is. Trying to find some kind of relationship between these 2 angles right here. Because remember what we said. I could find what angle 1's actually equal to if I knew what? What y was. I could find angle 2 if I knew what y was. Okay, so my key is to find what? Y. Okay, let's find what y is. So I want to find a relationship between these 2 angles. That's why I did what I did. So what did we say about these? They do what? Well, let's not say they equal 180 because that could mean a couple different things. They don't just equal 180. What do? They add up to be 180. Okay, that's very important. Okay, students every single year would say that. You're not the only one. Every single year they would say they equal 180. And I know what you're thinking. You're thinking, oh, if I added them up, then they're going to equal 180. but we got to say they add up to equal 180. All right, it's very important. So 7y minus 15 plus what? 10 times y plus 11. That's going to all add up to be what? 180.
You have a 1:30 dismissal, and you'll be leaving at 1:50. Thank you.
All right, now. No.
Good try, Tim.
Believe it or not, this was one of my best classes. Can you believe that? Can you imagine what my other ones are like? All right. Here we go. What are we going to do? Let's do some algebra. First thing I'm going to do is this right here. Agreed? So let's do that. So I'm not going to mess with this just yet. Plus, what do we do? Do you remember the word in algebra when we did this? Did your teacher do that with the little lines? It's distributive property. That's right. Okay, so what's this going to be? 10y plus 110. That's right. And that equals 180. Let's add some like terms. Remember that from Algebra 1, correct? So what are my like terms? 7y and the 10y, which gives you 17. How about 17? You're adding them together. And then minus negative 15 plus 110. What's that? What if it was a 10?
95.
Right. So that's 95. And that all adds up to 180. All right. Yeah, the rest is easy, right? Subtract 95.
95.
17y equals, what's that?
85.
85? Yeah. And then divide by 17. And you get, what?
Oh my God.
Is that 5? Yeah, I think it's 5. Okay? So, we found y. That's what we wanted to do right at the beginning anyway, wasn't it? So we found what y is equal to. So now I can go back up here. I'm going to write it down. Y is equal to what? 5. Now I can find angle 1 and 2, right? Once I find angle 1 and 2, the rest are really a piece of cake. Okay, pretty simple. So angle 1 is, let's do this. Angle 1 is what? 7 times 5 minus 15. Let's do the math. I'm going to show every step here. 35 minus 15. So angle 1 is what? 20. So that's one of them. So I got 1 out of 6 so far. Okay? But once we get these two, the rest are just going to kind of fall into place. You could do this. What did we say about angles 1 and 2? They're what? They're supplementary, right? So I could plug y in for this if I wanted to. And that'd be fine. It wouldn't be that hard. But I could also remember that 1 and 2 are supplementary. So if angle 1 is 20, then angle 2 is what? It's 180 minus what? 20, which is 160. So angle 2 is equal to 160 degrees. All right, so that's 2 of them. Tell you what, let's put these in another color. So what we say angle 1 was? 20 degrees, right? And angle 2 was 160. Does that make sense for angle 1 to be 20? Yeah, it's an acute angle, right? And so, yeah, it definitely makes sense. Now, there's a couple of these that we can do really, really easily. If this is 160, somebody tell me what angle 3 is without doing any math at all. It's also 160.
Why is 20 plus 160 170?
I don't even know what you're talking about. I don't have a 170 anywhere. It's 180. That's a 180. All right, here we go. What's angle 4? With just a little bit of math. Actually, you don't even need a little math, because if this is 20 degrees, then angle 4 was the same as 1, right? So that's also 20 degrees. But it also works if you knew 3, right? Because 160 and 20 is 180. So we're good there. Let's do some of these. Let's do 5. 5's super easy.
90 degrees.
It's 90 degrees because look, if this is a right angle, then this one right here is a right angle. Agreed? Because what we just finished talking about, you're not. So look, you wouldn't talk while I'm trying to teach. You wouldn't be sorry, or you wouldn't be talking if you were actually sorry about it. You gonna let me talk? Tim McKernan, he's the one that I'm talking about right now. I have to check my timestamp and send it to your mom. All right. So This is a right angle. This is a right angle. So that must mean this right here is a right angle as well, right? Because they add up to 180 because it makes a straight line. So 5 is also a right angle. We'll just put 90 degrees. Is that all right?
Yeah.
And let's say one more. What about the 6? 6 isn't that hard. So it's 70. This is where your 70 is, right? Because it's 90 minus 20. If you wanted to show your work, then you just put 90 minus 20 is 70. There we go. We got all the numbered angles, didn't we? All right. So the work was basically to solve for y. Okay. Once you get y, plug them in, find out 1 and 2. The rest were pretty simple. But you got to know the relationship. You got to know about corresponding angles and all that kind of thing. All right. So I think we're finished that lesson 3.1. So now I can officially give you the homework. Well, I'll tell you what. Is your locker still locked up or whatever? Okay.
You can cut them whenever now.
Yeah, just cut them.
You have to do it by yourself.
I have a car in front of mine.
So here's your homework. So it's section 3.1. No, you're not doing it now. It's page 111. And it's 1 to 21. Is that what I gave you?
Mm-hmm.
Okay. So we're actually, since we took a little long yesterday, we're actually a day behind from the lesson plan thing I gave you yesterday. So already, second day, we're behind, but that's okay. Tomorrow I'm going to give you a worksheet with stuff similar to this, all right? Just because I wanted to reinforce it a little bit with you guys because I think it's so important because we do a lot of this kind of stuff throughout the year, okay? So there you go. Get this done, 1 to 21 if there's paper in front of your locker. I mean, don't rip it apart, but, make it real nice.